All right, well, thank you. As Ted mentioned, my name's Zach Herrmann. I'm with Houston Engineering out of Fargo. What I'm going to be talking about today is the basin-wide flow reduction strategy, and we'll kind of get into an example project that's working its way through the development process. It's not under construction yet. However, we are kind of we're inching that way. As we move through that process, you know, we look at things, other objectives within the basin, and how can we integrate some of those other objectives into the project as well. So we'll kind of get into that. But before we get too far along, I do want to give just a little bit of background on the basin-wide flow reduction strategy. So, you know, I think everyone here is familiar with that. We've had historic flooding in the Red Basin. It seems to be becoming all more frequent. Obviously, we've got the large floods on the Red Main Stem. As you can see on the slide, there's that iconic photo of the downtown Grand Forks burning during the 1997 flood. I think we're all really familiar with what was experienced during 2009, 2006 in parts of the basin, 2013 in parts of the basin. Again, those main stem floods, we're all pretty familiar with them. But another thing that's also happening with more and more frequency across the basin is at the tributary level, or as we get kind of further up into the watersheds, is we're having a tendency to see more severe rain in localized tributaries of watersheds within the basin. And what that's resulting in is we're seeing larger agricultural damages that are occurring in certain regions because of these larger rains. So you can see on the slide here, there's some pictures of, this is actually a large rainfall event in late May of 2013 in northeastern North Dakota in the Park and Pembina River watersheds. About a 9-inch rain fell across the basin right in the middle of spring planting operations. What happened there was obviously that caused significant impact to the crops that were growing, but also because that runoff occurred on kind of a prepared seed bed where we really didn't have any growth in the field, had a lot of erosion that resulted. You see that in the lower left picture there, where there were large channels. I believe that's about 100 feet across and 4 to 6 feet deep was the gully that was cut, and that was a township road ditch is what that was before the event hit. So we're seeing those type of events happen on more and more frequency throughout the basin. That's driving kind of it seems to be a growing need for increased protection for agricultural crops within the basin, at least in the portions where they've experienced this. So how do we respond to these events? The Red River Basin Commission completed the long-term flood solutions report. Again, I'm not going to get into a lot of detail of that report, but at a high level, what's outlined within that report is there's protection objectives for various interests within the basin. So you can see on the screen from large metropolitan areas with recommendations of 500-year or greater flood protection, all the way down to agricultural land that has recommendations of a 10-year or greater flood protection. So there's these kind of high-level goals or objectives that are specified within the LTFS. They're not a mandate, they're not a requirement, they're kind of more of a recommendation for local practitioners to use when they're developing projects. That being said, they were developed with quite a bit of interjurisdictional or multi-jurisdictional buy-in from representatives from the interests kind of across the board that you see on the areas of protection on the screen. So another kind of key component of the LTFS is how do we respond or how do we actually attain some of these goals? There's a whole list of different different ways that we can attain the goals suggested within the LTFS document. What we're talking about today is kind of the top one there, or retention. Specifically, there's this whole concept of the basin-wide flow reduction strategy. What we're talking about with that is actually looking at within these tributary subwatersheds, we have these localized issues that are occurring on the landscape. If retention is used to help solve some of these issues that exist within these localized tributary flooding issues, if that kind of system can be put in place across the entire Red Basin, can we move towards a system where we actually have an effect on the flooding on the Red Main Stem? The goal is kind of put out there to reduce peak flows by 20% on the Red Main Stem. So, since that concept was developed, there's been quite a bit that's been done to date. The concept was initially developed doing some Mike 11 modeling during the development of the LTFS. That was kind of focused on the 1997 flood event. What that led to was just some high-level recommendations in terms of peak flow and volume reduction from the tributaries. Really wasn't verified that those goals could be attained. It was more kind of developed based on professional and local judgment of what they thought could be attainable within those tributaries at the time. What happened since the completion of the LTFS is we kind of had a lot of things that made a more detailed look at kind of validating those goals. come online. The first one was development of standardized models within the basin. So standardized hydrologic HEC HMS models within the tributary subwatersheds were developed. Those were all consistently developed, so they were kind of a apples to apples comparison tool available regardless of which tributary you were in. Also, the Corps of Engineers had developed a HEC-RAS unsteady flow routing, kind of a detailed hydraulic model of the Red River main stem. That kind of allowed for a look from the headwaters of the Red all the way to the international border, a detailed look at the hydraulics of the Red main stem. And also the Basin Commission through the Halstead Upstream study developed a standard flood scenario that was used to assist with kind of analysis across the basin. You may have heard that discussed as the virtual thaw progression or 100-year flood scenario. Once those models were available, there was desire to take a look at these goals that exist for the 20% flow reduction. Are they actually attainable? So essentially what happened at that level was the Red River Watershed Management Board on the Minnesota side of the basin and the Red River Joint Water Resource District on the North Dakota side, each of them within each their sides of the state sponsored moving forward with developing tributary detention plans, essentially identifying what is available in the landscape for storage. Very high level look, kind of looking at drainage area compared to storage as it relates to what's physically out there with the LiDAR. That's really about as far as it went with that effort. Those storage sites were modeled within the HEC HMS models, but that's about as far as I went with that. Once those sites were identified, the Basin Commission initially had partnered with the Fargo-Moorhead Diversion Authority and completed the Halstead Upstream Retention Study. What that did was essentially took all those tributary detention plans, tied them together, and looked at what's the effect on the Red main stem if we were actually successful at implementing the storage within the basin. That study actually showed that a 20% flow reduction was attainable. I believe it was about 560,000 acre-feet of water from Halstead to the south that was required to get a 20% flow reduction on the Red main stem. Also kind of ongoing currently is what's been called the Lower Red Basin Retention Study. Again, that's underway right now, but what that'll do is essentially take those tributary detention plans or storage plans that exist from Halstead and to the north or to the downstream, tie them together with the Red River main stem model, and then assess kind of the practicality of implementing the 20% flow reduction on the Red main stem. That's underway right now. We're still a ways away from completing it, but ultimately what'll come out of that will be kind of an overall basin plan for the 20% flow reduction strategy. Also, it'll be a tool that can be used for future efforts with the hydrology and hydraulics tied together in one model. Again, ultimately, we're trying to get to implementation. However, we kind of run into this issue, what this shows on the screen here is just some kind of highlights from moving through project development. We kind of start off on the far left where we have a problem or need that really is kind of starts the local level. We've got the basin concerns as well. We progress through kind of very high level site identification and analysis, moving through all the steps to ultimately get to implementation, which would be on the right side of the screen. Even though all this work that's been done, we still haven't had individual sites through this effort that have kind of, well, we have, but because of these specific efforts, they're still kind of at a very high level. So, what do we do to kind of take these projects and get them to the point of implementation? So kind of here is where the Red River Retention Authority enters. So, they were, well, I guess some background on the Retention Authority. They're a joint board that's made up of member districts from both the North Dakota and Minnesota joint boards on each side of the river. What they were successful in doing was securing funding through the NRCS, through their RCPP program, to essentially complete watershed planning on 22 individual smaller tributary subwatersheds. So each of these areas are areas that have experienced flooding similar to some of the slides that we showed previously that are having impacts up at the tributary level with some potential to work towards a 20% flow reduction. One that we're going to talk about specifically is kind of in northeastern North Dakota. You see it kind of highlighted as red there on the map. It's called the North Branch Park River Watershed. This particular area, this actually is where some of those photos were taken that we looked at earlier in the slide. It is within the Park River tributary. So if we go back and we look at the goals from the basin-wide flow reduction strategy, I'm not sure how well that shows up on the screen, but essentially what this shows is each of the tributaries listed, and then there's a goal for volume reduction and peak flow reduction out of each of those tributaries. So within the Park River, for example, we've got a 35% peak flow reduction recommendation and a 20% volume reduction recommendation. So that's kind of the objectives from the basin scale. But if we look at what the local issues are within the watershed, there's obviously everything kind of the issues that were first brought up from the local residents are all related to flooding. There's been very frequent FEMA disaster declarations within this particular area of the county. That flooding leads to pretty substantial infrastructure damages, agricultural damages, community impacts throughout that area. But most notably, that small town, Crystal, North Dakota, has experienced, their school actually resides in a low area, and I think during the flood that you see pictured here, they literally opened the doors of the school and let the flood kind of roll through the building essentially. But these photos show this is the same flood event, that rain event from late 2013, and some of the flooding that happened within that area. So once we have a good idea of the problems, the first thing we have to do is kind of vet what the alternatives are that might be feasible for the watershed. We've been talking a lot about retention, but when we look at what the solutions would be at the local scale, we can't just immediately jump to retention as kind of being the solution. So we kind of start with a blank slate, if you will. So try to put this pyramid together to kind of illustrate how we narrow the alternatives. You start at a very high level and kind of take things out as they kind of prove to be infeasible. So first, kind of starting at the top, we start with a process where we evaluate strategies or essentially just different types of alternatives or all the tools in the toolbox, if you will. We take that and we look at each of those different tools in the toolbox and figure out which ones fit for the job at hand. That kind of is kind of our first step at narrowing the alternatives. Then from there, we get into actually identifying things in the landscape that may work to solve the issue. We start at a very high level, doing again, trying to get to what the most feasible alternative is without investing too much time and effort into analyzing kind of every alternative under the sun. So kind of move through that process. Things get more and more detailed as we move along. Ultimately, what we're doing as we narrow these, we want to know kind of on multiple facets. Number one, can it achieve the objectives that the sponsors have for the project? Number two, can we minimize what the potential adverse impacts are because of the alternative? And then number three, is it technically feasible? Is it reasonable that we can do what we want to do out there from a like an engineering perspective, for example? Ultimately, at least through the RCPP effort, the preferred alternative is carried forward for kind of a detailed look at technical feasibility, social and environmental concerns, and then that's packaged within a plan. So what came out of the North Branch project is an off-channel retention site. What was identified is there's a section of land that's very flood prone within the watershed. It's situated in a fairly opportune location where we can capture flows right upstream of some of the major damage centers. Flows are diverted from the north of the site, from the Cart Creek to the south into the site. About just under 34 square miles actually is stored within the site. There's about 3,000 acre feet of storage available within the site. Provides quite a bit of flood damage reduction benefit to the watershed. The community of Crystal that has a major flood issue, this would actually reduce the 100-year peak discharges by about 30% within that community, as well as ag reduction of both overall acres of ag inundation as well as the duration of water that's on ag land itself as well. So that's all great from a flood damage reduction standpoint, but I did mention at the beginning, we also have to consider what about other objectives that exist in the basin. So that was one thing through the NRCS effort is we really want to look at what's out there for other opportunities. So if we are going to implement the flood damage reduction project, what can we do that can also move the ball forward for other issues that might exist within the basin? So if we take a step back out to the basin level, Drew touched on this a little bit on the previous discussion, but Lake Winnipeg, there's an issue going on at Lake Winnipeg with eutrophication of the lake, largely tied to phosphorus inflows into the lake. One thing of note is that the Red Basin contributes substantially more phosphorus loading to the lake relative to its drainage area size than the remaining basin to the lake. So kind of what's led to this is there's an internationally agreed to objective at the international border to meet the phosphorus standard, as Drew mentioned in his presentation. Roughly the 1990s phosphorus concentrations crossing the international border roughly about a 50% reduction in phosphorus is what would be required to get to that. So that's one concern. Another concern is from a wildlife habitat standpoint. You know, within the Red Basin, specifically within the portion that we were working in within the Red Basin, we're kind of in the eastern tier of the prairie pothole region. Obviously kind of an area of continental significance when we talk about breeding birds, breeding shorebirds, breeding waterfowl, things of that nature. So are there opportunities to provide for some enhanced habitat opportunities through the site? So what that led to is when we kind of get back to the site, you see the graphic on the screen here. We looked at different management practices that could be done within the site to help accomplish both water quality and wildlife habitat objectives that exist within the basin. So from a water quality standpoint, you know, obviously there's some benefit there just by having some increased residence time with the water. Any particulate bound phosphorate would have an opportunity to settle out. However, there is, you know, that within the Red Basin, there is some research that supports that dissolved phosphorus may also be a large issue to some of the concentrations that we see. So something that we're working through right now is options of what we could do for biomass management within the site. We've talked about things like can we do cattail harvesting within the site? Obviously that creates some issues in terms of what do you do with the biomass once you've harvested it and things like that. But other things like rotational grazing and things like that within the site as well. Those are things that are kind of being worked through logistically. They kind of have to be fleshed out in terms of how they'd be handled administratively, but things that we do see as having potential within the site. So what you see on the map is the yellow is an upper portion of the pool that we think we could incorporate fairly easily, an area for some biomass harvesting, as well as potentially doing some rotational grazing for the remainder of the site to help pull off some of the biomass as well. What that results in, you know, one thing I just want to point out is the percent reductions you see here are largely kind of based off of some monitoring work that's been done on the North Ottawa project. So it's been applying those, assuming that we have similar management practices within the site to attain those goals, but pretty massive phosphorus reduction potential within the site. Obviously, when we get down to the tributary outlet, those percentages drop quite a bit, but you know, it's moving, it's a step in the right direction, if you will, if we're able to accomplish that. So on the habitat standpoint, you know, obviously within, well, this site itself, actually, there's several drained wetland basins within the site. Actually, a large part of it is floodplain wetland. That's substantially degraded, largely to kind of drainage activities and things that have happened in the upper watershed. So through the operation of the site during non-flood times, we're trying to operate those inlets into the site to help kind of mimic what we think the historic hydrology would have looked like in this area, to help kind of reestablish the wetlands that exist within the site. Ultimately, this would result in a pretty large chunk of contiguous combined upland and wetland habitat. That's just something that's pretty unique to this part of the world that we're talking about for this. So we do see that as another opportunity as well with the site. So with that, just in conclusion, you know, we've been talking about flood control. At the end, we hit on these different resource concerns that exist in the watershed. I would just maybe leave it with everybody as just a challenge as we work through this. We're really working towards a basin-wide flow reduction strategy, but as we kind of get into the weeds of what implementation looks like, we really need to be thinking about what other opportunities might exist to address some of the other resource concerns within the basin. So with that, I just want to thank the Basin Commission for letting me represent you guys today and the opportunity to talk. So thank you.